Hi everyone, I hope you are fine and welcome to another video of Mastercam. So we have already started the video number 5, which is all about the multi-axis toolpaths, and we have covered the topic of introduction to multi-axis. Actually, it's introduction to the multi-axis toolpath. We get to know how the multi-axis toolpaths actually work. So today we're going to start the next topic, which is 3+1 and 3+2 rotary positioning toolpath. So let's get started. So here I've been using the Mastercam Design 2023 version, and we are going to create a profile for our rotary positioning. So let's create a profile using the wireframe method. So I'm going to use an irregular profile. Let me say that I'm using the ellipse command, make it center, and make it like this, ellipse. Let's give it an random sizes, like A size is 45 and the B size is 30. Okay. Now what I'm going to do is I'm going to extrude this wireframe using the solid command, and go to extrude. Select the chain, okay, and make it this side direction in this direction or in this direction. Let's make this in the opposite direction. Make this out 70 millimeters. Okay, so this is we have created a ellipse solid profile, solid model here, and we're going to apply the rotary positioning tool. For that, you need to have a appropriate origin or toolpath for that. So therefore, I'm going to create a plane for this thing. I see that the z-axis in this direction. So we actually want the z direction in the upward direction. Okay. So what we're going to do is we're going to create an other plane by just drag and drop here, okay, at 0, 0 positioning, okay. So now what I'm going to do is just rotate by using the dynamic system. Let's make this rotation at 90 degree, and this rotation of z-axis at 90 degree upward direction, okay. This is very simple tool to set your origin. So our work plane is set at here. So let's define this plane a rotary position. A plane rotary. Okay. Click OK to do this. Select this plane for all your construction into your coordinate system. Now what we're going to do is we're going to set our machine. So go to machines, select mill as a default, and go to Toolpaths. Let's define. So here we have the multi-axis tab open here in the Toolpaths, and we have a lot of toolpaths here regarding the multi-axis. So here we have the rotary positioning toolpath here. So this is, we are going to select this. This is a 4-axis toolpath. So for that, you need to select your cutting tool. So for that purpose, you need to select a ball nose, because this toolpath is specifically for the ball nose operation. So just go and select when using the filter option. So I'm going to select the 5mm and mill, ball nose and mill, and we'll make the RPM 20,000. Let's give in a random. You need to calculate this regarding your machine setup. Okay. So give the tool number 1. It's my tool number 1. We are going to this folder. Set is at default. How about the cutting pattern, which is the most important part of this positioning system. Okay. So in every toolpath, we have the cutting parameters, and this is the most important thing. You have to select the appropriate surface for the which you want to machine. Okay, So here it says that surface, which is 0. You need to select a surface which we want to machine. So just click here and I'm going to make this surface. Okay, this surface and this surface. So I just want to remove material from this surface. So I just select all the surface. Click OK or end selection. Now the next thing is cut control. There are two different methods here, the rotary cut position or axial cut positioning. The rotary cut position is always around the rotation or circumference of this part, okay? But in the axial position, it moves along its axis of rotation, okay? So we're going to use both of these, and let me show you how it actually works. Now it all says that the compensation type, we'll just set the computer to calculate the compensation either to the left side or right side. It will automatically select the direction. Now other things, if you want to leave the stroke on the drive surface, you can just give the stock here. If you want to leave stock, for example, just want to leave 1 millimeter from the surface, it will definitely leave 1 millimeter from the surface, and then the surface will be removed. So if you want to remove the 1 millimeter from the surface, then definitely I'm going to write in negative direction. Okay. So I just don't need to remove any material from the surface, therefore I'm just go and write 0. So cutting tolerance is 0.025, which is enough. And the direction of close contour. So this is close contour in some conventional type system. Either you want to climb or conventional system cutting method you use, or the direction of open contour is one way or a single way. If you want to use the one way, it's okay, or zigzag way, it's always okay. So just select the default setting. How about the tool axis control? So definitely the tool axis control is very important for the existing system. So therefore, and the x-axis will be in the by default setting to control your rotation. Okay. So by default, it's an x-axis because x-axis is the k-axis, y-axis to b, and z-axis to c-axis. Okay, and so you need to select that which axis you need to control, either the x-axis, y, or v. Okay, rotation position system. So by default, it's using the x-axis. Now the other thing is that you use the rotary cut position using the center point. This is the center point, or you don't need to send away. So make sure that this option should be done off, because we don't want to use this center point positioning system. We use this surface position system to cut the material according to our surface. So axis damping length is 2.5 millimeter. It's all about this length, which is showing 2.5 millimeter. If you want to make it closed, you can make it closed. The lagging angle is 0 degree, and the maximum step is 2.0. The more the step, the more roughing operation will be performed. The close the step, for example, let's make me 0.5 millimeter will be close to the tool radius, and definitely it gives more surface finish to the workpiece. So we'll define this step, maximum step, according to the tool which we're using with. Okay. So by default, let me make this 1 millimeter. Okay. So how about the collision control? Because you have to select the surface which you don't want to machine or check that whether the cutting tool will not cut that material or collide with that material. Okay. So here we don't have any other surface where the cutter will collide that surface. So the next thing is the linking parameters. You have to define where is the clearance position. It's all about the 100 meter from that point. And how about the retract position is in an incremental position from the 10 millimeter from that plan, where the origin is. Okay. And the feed plane is 2 millimeter. Definitely it will be also in an incremental position according to the surface. Okay. So let's click, if you want to have some other parameters, or you want to make a roughing operation, you want to remove the excessive material from the stock material, then you use to rotary cut depths and define the minimum and maximum depth. And you have to find out how much roughing you are need to perform. Okay. So if you do not want to perform the roughing operation, then select. It will definitely automatically be on the material if it finds out. Okay. So next thing is the additional setting. We have the rotary planes. We have already set the rotary plane positions, and if you want to select the pull, then click on. These are all the other options which are definitely the same as on other 2D toolbars, 3D toolbars. Okay, so just click OK and get your results. So here what you see that the toolpath is being generated for this surface, and it's all about the rotary position. Okay, so let me show you backplot setting. Go to click. So this is how the rotary position works. Actually, the cutter is rotating about this workpiece, but in actually the workpiece is rotating about the tool. The tool is in a fixed position. So let me go to option, and here we have the backplot option. Simulate rotary axis. Okay, check this option, click OK, and now this is. So you see that z-axis z-axis is called the c-axis, and c-axis is rotating along, and the cutter is cutting the material. This is how we can do the rotary positioning axis. Okay, so this is 3 plus 1, we call it 4 axis. So we just we generate a simple model for this profile. If you have a complex model, the procedure will be same. So this is how it works. So let's go and select other options, go to parameters, and we have another method of cut, which is axial cut. So I just select the axial cut and the tool axis control. So the rotary cut positioning system or rotary cut options have been disabled, and the axial cut options are enabled now. So what you need to is you need to select the starting, which is all about the 0 degree, and this swipe angle where you want to cut the material. So 0 degree to 90 degree, or other angle on the from 90 to 360 degree, you don't need to. So therefore you have to set the swipe angle. For example, the maximum incremental is 0. Let me say that the maximum incremental is 1, and the starting angle is 0, and the ending angle is 360 degree. Okay, so how it works, just click OK and you will see that. So this is how it creates 1 degree, 0 to 360 degree overlap. Okay, and how it actually works, just go and check the back plot, and this is how it actually works. It's moving along the axis. This is how it works. So you need to select your appropriate setting for rotary positioning. Either you have to select a cutting method of axial cut or the rotary cut. But definitely it depends upon the profile, or it depends upon the geometry. Okay. I have generated a geometry which is both compatible with the rotary and the axial cut. Okay, start. So this is how the rotary axis positioning works. I hope you understand. Stay tuned for more videos. Thank you.